While in many of these I tried to explain the concept of where the formula comes from, this one is a little trickier to be able to do that for you. I do know ways to derive this formula, one through a calculus method, another through kind of something that's a little tricky as well. So really for me to kind of bring out that where does this come from, I don't really have the ability to do that easily for you. But I do want to note a few things. One, this 4/3 is kind of unique. Also notice it is r cubed. It's very common for students, pi r squared, and just to forget that this is a cubed environment. So be careful with that. Here in the first example, there's nothing really tricky here. And partly why the sphere is just so quick and simple is that there's really only one number, one variable in the formula. And so once you have that number, the game is over. It's very, very simple. Here, this time, they gave it to you as a diameter. Notice that the 10 is over the center of that segment. Notice that there is no center point. So that 10 is the diameter. And that means, of course, we would use 5 in that calculation. One of the things that many of the ACT, SAT kinds of tests do, as well as I will do this, is they work you through a second formula to get to the final one. And they'll work you through what's called surface area. Now, this 4 pi r squared calculates the surface, the area of a surface of a sphere. And so what they will often do is use that formula to tell you what the surface area is and have you work your way through it to obtain the radius. And then that radius just simply goes into the new formula. It's just an extra step. It's just a way to kind of test your ability. And ultimately, it's a way to make very simple questions just a little bit trickier. And again, these are very simple because there's only one variable to find. And if you find r, then you've got it, right? So nothing tricky here. This is partly, other than the 4/3, but r cubed. In this case, our number is a 12 cubed. And that just simplifies to 2,304 pi centimeters cubed. A big number, but nothing scary about that process. Here we try to make things a little bit more interesting by making a hemisphere. Hemisphere just refers to half of a sphere. So this is like, let's say, the top half of a sphere. And so to calculate that, that would be 1/2 of 4/3 pi r cubed. And if you do that work, this actually simplifies. Maybe I'll just do this so you can see it, to 2/3 6 cubed. And so again, 1/2 of 4/3 is 2/3. Maybe you already knew that in your head, but just wanted to show you. That's 144, so that's the top part. And the bottom you know to be a cylinder, right? So this is pi r squared. That would be the base times the height, which happens to also be 6. And that's 216 pi. And those two numbers added together give us our final answer. And so this would be the composite volume of those two guys together. The tennis ball or the tennis can question is one of my favorites. This is a little bit different variant of it. But what it does is it usually hides a little bit of information from you. In this case, it's all been given to you. But usually we use the ball to help us with the radius, diameter, or height. But in this case, both of those were provided. So we want to know the volume of the air in the can, basically. So that would be the large cylinder that has a base of a circle, pi r squared, times the height of 26. This gives us 2,106 pi. Now that is the entire can's volume. We have 2 tennis balls inside of the can. They are 4/3 pi. Their r is 6 squared, right? and cubed. What am I saying? Cubed. There was almost the trick, right? And that is 576 pi. And that is, again, make sure when you're doing these, there are 2 of them in there, and that's why I've done exactly that. When you subtract those values, you get your final amount of volume in the can of just the air. And this would be that solution. Kind of a fun one, right? Make sure, again, this 2 implies that there are 2 of those spheres inside of there.